Okay, good morning everyone. Welcome to the third talk this morning at VCF East 2024. I would like to introduce to you Ron Nicholson. Ron Nicholson was part of the engineering team for the Mac, as well as Director of Engineering at Amiga. I think Ron has been involved and owns part of the patents on a big handful of patents to do especially with the Amiga 1000. And this morning, I think Ron would like to tell us something about the Mac.
Thank you, Rob, for that very kind introduction. Thank you for the event organizers for giving me this opportunity to talk. I'd also like to thank the museum here. It's just a wonderful museum. I've been a docent at the Computer History Museum in Mountain View, and I know how important it is to have exhibits like this to show the general public the influences of technology on their life. So, why am I giving this talk this year, even though I've given talks in previous years on a different computer? And that is, this year is the 40th anniversary of the introduction of the Macintosh. In January at Flint Center in Cupertino, it was first unveiled to the public, although I might mention that, the rumors of the Mac had leaked much beforehand. And at the Super Bowl in January, 40 years ago, they showed a famous commercial directed by Ridley Scott, and I'll talk a little bit about more of that later. Now, at these events, there are two things. There are expert speakers because they've built various things or tinkered various things, and there are exhibits of old stuff. So I'm not really an expert on a lot of this stuff. I find out when I go to retro computing events that a lot of the people who are currently into reverse engineering and demo scene actually know more about some of the stuff that I designed 4 decades ago that I can barely remember than I do. So between being an expert speaker and a historical exhibit, I suppose I'm a little bit more of the latter. So that's what you're sort of getting now. So I speak about this subject with a little bit of trepidation because it's been extremely well covered. There are over a couple dozen books on Apple and some of the characters involved with Apple and the Macintosh itself, including 2 by Pulitzer Prize-winning authors, one by a member of the team itself. I'll reference it. If you want good information, the books by John Markoff or Stephen Levy are good, and let's see, the book written by Andy Hertzfeld, he was involved with the Mac for longer than I was. Those are good references. If you want a bad reference, the movie written by an Academy Award-winning screenwriter and a Academy Award-winning actress are interesting works of speculative fiction about myths. So if you're into that stuff, that's all that movie's good for. So basically I was involved there. I was there to participate. I wasn't a key player. I was a junior engineer on the project, and I will talk a little bit about how I got lucky as a junior engineer to end up being a part of something that is now an exhibit at this museum. In fact, let me read off what the plaque on the exhibit at this museum says, if I can pull it up. I just took a photo a minute ago, and it turns out the curators did a good job. They have a Macintosh 128K there, and it says, the Mac was the first successful mass-market, all-in-one desktop personal computer with a graphical user interface. It turns out all those words are important. The curator did a good job. Okay, the first thing I will do is, if you want a more complete talk about the Mac and what happened 40 years ago, the Computer History Museum in Mountain View had an event celebrating the 40th anniversary, and they have a very good tech department. They have a YouTube video that went online hours after this event. I recommend this, it's far more interesting than what I have to say. They not only show the commercial, but Mark Murray tells an incredibly entertaining story that makes the commercial even more interesting, so I won't play that here. And also, Bill Atkinson and several of the key players talk about how they joined the Mac project. So I recommend you look up the Mac 40th event at the Computer History Museum for a complete, more thorough telling of the story. That event, by the way, I went to the Mac 30th event, and it was undersold. The audience was really small. At this event, it was sold out. The Computer History Museum had actually, even their overflow room was filled up. It was so filled up that I had to pull strings to actually get into the event myself. And Dave Polk tells a joke about how another key player also had to pull strings to get into the event, and he pointed at Woz. Okay, the one thing I was disappointed in this event that they had at the 30th event is they talked about the Mac hardware. At the 40th event, they talked about software, sales, marketing, but they didn't have Dan Kotke or Rod Holt or anybody like that on the stage to talk about the hardware. So one of the things I will do to fill in that is I will talk a little bit about the little bit I know about the Mac hardware. Let's say that. So here's most of the Mac team on the stage. They managed to get them together for the event. I'm sitting there sort of in the middle, Woz, in front of Woz. Bill Atkinson, who designed most of the GUI software himself, is there. Other key players, Steve Capps, who later on went to design the Newton, a host of famous names up there in the history of computing. So, I dug this out of my files. I managed to find an old lab notebook where I had taped this into the back cover. So if anyone needs evidence that I was actually there. So how did I get involved in the Mac project? Well, it turns out I've been involved in 3 engineering projects that shipped, were fairly successful in different parts of the world or in different market categories. And I consider myself extremely lucky to have been involved in these projects because I worked at several other companies, including HP and the now long-gone Silicon Graphics, where we worked on tons of really interesting, fascinating projects. That's another talk, that all except for one got canceled. So I consider it an extreme matter of luck that some of the stuff I worked on actually shipped. So how did I get lucky enough to be involved in the Macintosh project? Well, a lot of it's pure accident. Why is this up there? This is obviously not a computer. Well, first a little bit about my history. The previous speaker talked about his history with computing. I actually learned about computing even before the sort of VIC 20 days and even Altair days. I learned to program at first on a programmable calculator. They had one at school, an HP desktop programmable, and then later on learned to do Fortran in punch cards on a punch machine, where the key thing was making sure not to drop the deck of cards and your whole program's out of order. So at college, I missed the beginning of the microcomputer revolution. I was too busy with my homework to have caught the article on the Altair, but the next year I read the Popular Electronics article on the Cosmac ELF. There's a great exhibit of that showing right here, and I actually built one of those. And at the same time, one of my other hobbies was paper airplane contests. Why is this relevant? Because I went to a paper airplane contest in San Francisco and was talking with another contestant there, and he said not only was he interested in paper airplanes and model airplanes, but he was also interested in small home computers, and that person was Jeff Raskin. So I met him purely by accident because we both were interested in paper airplanes. I got to know him fairly well. I actually went up to his house a couple times and talked to him about various things, model airplanes, music. He used to be a professor of music, and I was learning to play the Baroque recorder at the time. He pointed off in the corner to what he did for his day job. He had a small consulting firm called Bannister and Crun, and he and Brian Howard, he said, oh yeah, we write manuals for various people, big companies, but also, we got hired to do a manual for these two guys in a garage. I didn't know what that meant at the time. So how I got hired at Apple wasn't through that. I didn't know he actually was involved at Apple. How I got hired at Apple was a pure accident. So I went to the National Computer Conference in 1980, and I was such a nerd that I wasn't interested in going to a computer conference to find where the good parties were or anything like that. I actually went to the technical sessions to listen to them talk about the new technology. So here I am sitting in the audience, much like you are, in a folding chair, and these two engineers next to me are talking about this problem. And one engineer worked at HP and one didn't, and the one who didn't said, I work at this company and the engineers just don't know how to solve this problem. So me being a smart aleck, I lean over and said, well, the obvious way to solve this problem is this, this, and that. I no longer remember what I said or what I was talking about, but the guy who didn't work at HP leans over and hands me his business card and says, come interview, I have a job for you. Completely out of the blue, turned out that he didn't work at HP anymore because at HP he used to be the manager in charge of the HP 35 and 45 pocket calculator. He was now a VP at Apple. So basically, I was sort of hired on the spot to be an engineer at Apple by an accident of who I sat next to at a computer conference. I wasn't even thinking of sending him a resume or anything like that. So what did I do at Apple? Well, I didn't immediately go into the Mac project because it sort of didn't really exist at that time. I was hired into the Apple II peripherals group, but I learned several things there that led to my being involved with the Mac project. So let's see, there were a couple, there were these printer and serial cards that were sort of, didn't meet the specifications, so I was chartered with designing a new serial card. The serial card I designed, the super serial card, actually ended up on Apple's price list for 11 years, which is longer than a whole bunch of other projects. That was designed by myself. I did the hardware. Larry Kenyon did the firmware. So now, yeah, here's the super serial card. One thing that happened at this time was the senior engineer asked me to actually analyze whether I really needed all those bypass capacitors up there, because even though they only cost a penny a piece, if you actually end up shipping 1 million of those, and Apple may have, that penny a piece adds up to far more than the annual salary of a junior engineer. So I was definitely chartered with making sure that I had the minimum number necessary to take care of things like ground bounce and noise. And that led to yet another project that I was assigned to at Apple. Let's see if that's here. Yes, that showed up. The previous slide showed the Apple II with the plastic connector. The ones that shipped all have little metal back plates. And why did we decide to do that? Well, at the time I joined Apple, the FCC was letting personal computer companies, personal computers did not fall under the categories that needed to be checked for RFI compliance, radio frequency noise. How many people in the audience have ham radio licenses? Yeah, quite a few. You know what the bane of ham radio operations these days in an urban setting is RF noise. All the LED lighting And all the switching power supplies just generate a ton of noise that interfere with radio signals. And the FCC wasn't really concerned about it with hams, they were concerned about it with TVs. And so, like the Ataris had a metal can on their digital logic to decrease the amount of digital noise emitted. And the FCC was going to apply those same rules to Apple's cash cow, the Apple II, which would, if they applied the rules as it existed, would have taken it off the market. So the person who designed the Apple II power supply, and by the way, that's RF clean. It's the rest of the Apple II that's RF noisy. He came to me, and because I had studied, ground noise and other things, he assigned me as a junior engineer to help Dave Antula figure out how to get the Apple II to pass RF noise testing. Now, let's see. Oh yeah, here, Rod Holt. I'm standing. Rod Holt is here between myself and Dan Kotke, who I think Dan Kotke has been out here to speak before. Is that correct? Yes. So let's see. So how is RFI testing done? Well, it's normally done by aiming an antenna at the unit under test and measuring it as you rotate it on a turntable and operate it in various settings. Now, this is a PR photo of from Apple of one of their many RF test sites now. Faraday cages, very well shielded. Their facilities are so enormous, they've actually torn down 2 smaller RF testing facilities. But let me set the picture. When I joined Apple II, when I joined the Apple team, Apple Computer, when I joined Apple Computer, all of engineering fit in one-story, medium-sized building. And I mean all of Apple engineering. The Lisa group was in one corner, software was sort of in the middle, they had the Apple III team in another corner, Apple II and my peripheral team in another corner, the people doing Apple software off to one side, the laboratory benches sort of on the east side of the building, parts bins, stuff like that. Oh, by the way, I discovered after I got to Apple that my old friend Jeff Raskin was in the northwest corner in a small cubicle. His cubicle was filled with books. He had an electronic keyboard there. He had a bookcase. I do remember on top of his bookcase, he had this little breadboard that wasn't being used. I'll talk about that little breadboard later. But anyway, obviously this RF test center would not exist if all of Apple engineering fit in one small building. So what does Rod Holt and Dave Antula do? They send us out to a ravine somewhere between Pescadero and Pacifica, where the ravine is steep enough that the hills block all the RF signals from Silicon Valley and from Japan in the north and stuff like that. I think the opening into the ravine was aimed out towards the South Pacific, where we assumed there wouldn't be too much RF interference. And so we set up the Apple II there and do RF testing and determined that of the various solutions, no, we didn't need to put a tin can to barely pass, which is all we wanted to do, the FCC testing. We decided to paint the inside of the Apple II with a conductive coating. And now, how does that affect the Mac? You'll notice that if you open up a Macintosh, it's beige on the outside, but it's got sprayed conductive coating on the inside. So we sort of learned that technique at Apple from the testing we did on the Apple II and applied it to later projects. There's some random signatures on the inside of the case that some of you may be interested in. But anyway. By the way, for trivia questions, if anyone here is interested in how to create an interesting trivia question for something or another, the question is which Mac models have the signatures inside and which Mac models have Steve Jobs' signature inside? And that's almost a trick question. So anyway, that's a good, okay. So let me move on to the next one. The next person I got involved with that would come to be part of the Mac project was due to what I learned at when I was in college at UC Berkeley. And I have to throw in something a little computer sciencey here, since this is a talk at a computer event, sort of. So anyway, even though I learned to program in Fortran and could do digital logic design, I still sort of didn't really understand how computers work. It was sort of black magic. How does this Fortran, go and cause its digital logic to actually do something you want? And it wasn't until I took a course, not from the CS department, which is where this is commonly taught, but from the engineering department, where I learned about state machines. And finally, I figured out, a state machine can sequence through the instructions after reading them in, and suddenly designing computers and computer parts no longer became magic to me. But state machines still required a lot of parts until monolithic memories introduced something called PALs, which are programmable array logic. And this particular PAL, the 16R, that's a 16R6. I think we use the 16R8 in the Macintosh. But it allows you to essentially just program the logic equations for a state machine in there and have it sequence through it. I knew how to do that. I used PALs for some of my prototypes in the lab. And sitting next to me was another engineer who was a wizard at using these things. He could use them to puzzle solve and really make minimal logic systems using PALs. And that engineer, who I learned to work with, we learned to design and review each other's work, was none other than Burl Smith. Burl Smith is the designer of the Macintosh motherboard. And the first several prototypes, that little thing sitting on Jeff Raskin's bookcase, was designed and built by Burl Smith. And he's interesting because he doesn't have a degree. He just is really good at solving logic puzzles. And so when Jeff chartered him to build a certain thing that was suitable with the bitmap display with the minimum number of chips, he managed to do it in even far less chips than an Apple II. And that was a little prototype sitting up there. It had a 6809 processor, and you could put 16K of memory in it, but they decided to need a little bit more to run a graphical interface. So they bumped the memory way up to 64K, which the chips were just becoming economically affordable at that time that he built the prototype. So, but I think the software engineers looked at that and said, if you really want to do, graphics on it, the 6809 is a little weak. It's barely more powerful than the one in the Apple II. We want a better processor. But Jeff didn't want him to build a prototype with a lot of parts. But Burl, being brilliant, figured out, I could add 2 chips to it and use a 68,000 with still only 8-bit memory bus. So the second prototype that I remember being on top of Jeff Raskin's bookcase was an 8-bit bus computer, even though it had a 68,000 in it. So, yeah, 68,000. Now, how I got involved in the Mac project, pulled off the Apple team and worked on the Mac project, is it turned out that because of Burl's design, you could no longer use software timing loops to run the disk drive. And since they wanted a disk drive on the Macintosh prototype, some way to at least experiment with reading disks, we needed to find a solution for that. And Wendell Sander, who's designer of not only the IWM, but before that he did the Apple III, he sort of breadboarded up a prototype solution, said, well, you could use this, but it was a lot of chips. But then, he's a semiconductor engineer, and Walt Brodner in a cubicle nearby also used to design custom chips. He says, this is now in the range where Apple can afford to design a custom chip. And so somehow Rod Holt came by, since I had worked with him on the RFI project, and said, you're conscripted. You're going to help Wendell turn the integrated WAS machine, the disk controller, into custom silicon. And that's sort of how I ended up being a project manager on, I think, the 2nd, 3rd, 4th, and 5th custom chips ever done at Apple. So let's see, what else do I have to say here? Okay, so I'm on the project, and I wasn't really designer of most of these chips. As you know, designers have a large team, sometimes of hundreds now to do chips. I think at Apple we had a large team of 3 or something like that. But anyway, my job was mostly a project manager, wrote the specifications, and then served as test engineers as the chips came back. So I actually did write the specifications for the IWM and the clock chip, which I'll talk about a little bit later. But here are some wire wrap prototypes. These are the 16-bit bus versions of the Macintosh, because again, the software engineers said, 64K is a little constraining. We need a bit more memory, and so they bumped it up to 128K. Dan Kotke did a lot of the wire wrapping after Burl got promoted to, full designer of the Macintosh project. But one piece he didn't wire wrap, of course, was the socket for the IWM, since it hadn't been, the pinout hadn't been decided, until well after the Macintosh design was underway. So that is a piece where I contributed directly to Mac prototyping. Wire wrapping. So the one other chip I worked on, let's see, where is it? Oh yeah, it's in this corner. That's the clock chip. At some point in time, Steve Jobs decided, you shouldn't have to type in the date and time when you first boot up your computer so you can see what your calendar says or something like that. It should be able to tell its time. Burl figured it out. Burl goes out and looks at the existing computer clock chips, and they're all like, 24-pin packages and require several chips for bus interfaces. And when Burl talked to Steve about putting that in the board, Steve basically says, you can't put all those ugly chips in the board. That's just too many chips. Seriously, too many chips. He was really actually concerned about the aesthetics of the board. And actually, sometimes it was a fight because he wanted to change the layout that was designed for electrical compatibility to make it look better. It turns out the changes he made did not affect, the electrical tolerances on the board, but it was still interesting that he did that. Anyway, so the first 2 chips I was charged to do were the disk controller chip, and the second one that I was supposed to write a specification for and go out and find vendors for was the clock chip. I have to say that I think one of the vendors screwed up, and their CMOS process was not good enough to make the thing static tolerant. So let's see. Other minor contributions I made to the Mac project is, I said that I helped, Burl and I, helped design review each other's PAL equations. I think I moved the audio buffer in the memory map by, like 1K to make it less fragmented. So that's my contribution to the software architecture of the Macintosh, moving the memory address by 1K by, tweaking one of Burl's equations. Another thing I did, which is, again, I can talk about engineering again, is the Macintosh actually has 2 DMA channels. One of them is used for audio. Why isn't the other one? The other one isn't used for audio because the Twiggy disk drive is a variable speed disk drive, and they needed some way to control the disk speed. But it turned out that the analog channel into the A to D did not have enough resolution to control the disk drive to the precision that he decided was needed to keep the error rate low enough. And Burl was scratching his head and goes, do I need to add more chips to the board and have them get mad at me for adding too many chips to the board? And I suggested a technique that actually they helped develop at UC Berkeley, and that's basically noise shaping in DSP, where you can use a high sample rate signal to and dither it or tweak the least significant bits so that when it's low pass filter, it actually can represent a higher bit depth or a more accurate analog control. And so I suggested that to Burl, and he went and talked to, I think, Larry Kenyon on the software team and said, oh yeah, we can implement that. And so Burl didn't have to add a chip to get a very precise disk speed control on the Macintosh. So that's a teeny bit that I helped out with. So this is actually a slide that's meant for a completely different talk, but it is connected because I told you that I was chartered to get 2 clock chip vendors. Apple had recently been burned by a chip that didn't have a second source, so I had to get 2, not 1. And to get one of the second sources, he gave me a phone number and said, call this guy. I go, why? He says, well, we need another vendor for the clock chip, and the best IC designer I know is Jay Miner. So that's how I got introduced to Jay Miner. And it's surprising he said that because Apple had several chip designers internal, including people we recently hired from VLSI Technology and something like that. So I thought that was interesting. And getting to know Jay Miner actually led to a second phase in my career. But that's another story. So remember, the description in the museum, let me get back, if I can get back to it, said it was the first successful mass market. And to be successful in mass market, you actually have to ship and ship in volume. And so, you know, one of Steve Jobs' quotes that go around is, real artists ship. Yeah, because he considered designing products like this not just engineering, but art to change the consciousness of the world. But he said it doesn't really work to change the consciousness of the world if you do an R&D project and write a tech paper. You know, you got to get it in the hands of the public, since that's what changes the world. And so the product needed to be something that could ship. And let's see what my order of slides is here. Yes, and so how did it came to be something that could be shipped with a good graphical user interface? And that turns out it goes back to my friend Jeff Raskin. And he is key because the famous story is told about how the Apple team went up to Xerox PARC and stole their ideas. No, that wasn't true. Jeff Raskin actually arranged for Xerox to make an investment in Apple, and they got a significant amount of Apple stock in exchange for a technology exchange. And Jeff, being a visiting professor from San Diego, knew a lot of the researchers at PARC, and so he could arrange the visit and knew what Steve Jobs would see. But it wasn't just arranging the visit to Xerox PARC to show them some of the future of computing and graphic user interface. I'll actually, do I want to go back? Let's see. Yeah, I'll skip back to that slide. Yeah, just before I got to Apple, maybe 6 months to a year, he published a paper called Computers by the Millions. And this is a seminal paper. Stanford has an archive copy, so if you look up that title by Jeff Raskin in the Stanford archives, you'll find it. And basically, you know, the Apple II was being sold to mostly hobbyists. You had to type in BASIC and stuff like that. Or if you were a kid, you had to know how to break the copy protection on your friend's disk so you could make a copy of his game. So, you know, that's a pretty geeky audience. So Jeff wrote a paper saying, well, no, if we really want to get into mass market, we need to do at least two different things. There's more reference in the paper. I'll talk about 2 of them. But he said, first, you've got to be able to manufacture it in much higher volume than the Apple II. And to do that for a company of our size, we have to, you know, the cost of inventory of parts means we have to be able to create a computer with very few parts. Parts cost and the number of pins and sockets on the circuit board was significant back then. And that's where Burl comes in, because he, again, being a wizard at minimizing designs, that fit in exactly with what Jeff needed. And so that's how prototyping the Macintosh came about, that Burl could actually squeeze the number of chips down to where Jeff thought it was in the price range of a quarter of the price, or maybe even less than an Apple II. It turns out he undershot a little, but I'll talk about how that turned out later. The second thing he said is to sell to the general public, we need a computer that's usable by more than computer geeks who know how to program in BASIC or copy protect disk and stuff like break copy protection and disk and stuff like that. He wanted to be able to sell. The word he used was a typical family. The word used later is the typical man in the street. The way to conceptualize it, at that time, most of the people in the engineering building, the engineers were all guys, and so the way they phrased it, and even I phrased it, was a computer that your sister or mother would want to use, right? Let's see. How many of you here were influenced in your life by the first personal computer you got? So it's a lot. How many of you were influenced by a first personal computer from either your father or your mother? A few, see? So that's what Jeff wanted. He wanted the influence to be so spread that generic families would be influenced by what other family members were doing with the computer, not just the father who needs one for business or the kid who likes to tinker with electronics. So to do that, I think he proposed at least two things in the paper. One, he said, to keep the programmers from going crazy and creating interfaces that people couldn't use, the hardware and software environment would have to be extremely restrictive, so that if you figured out a good paradigm, the software engineers would sort of be stuck with that, because that's all the hardware would be limited to do, and that's all the software support system could be doing. Now, programmers hate that, but I think that's one of the things that led to the whole idea of the Macintosh being the way it is. Let's see. Computers by the million, the paper. Do I want to back up a little? Both Jeff Raskin and Larry Tesler were fans of computers with no modes. As to why, Larry Tesler tells it was user testing. So here I'll tell my story. I think a lot of it was due to the fact that Jeff Raskin, and it turned out, I think maybe 3 or 4 members of the Mac and Lisa team were slightly dyslexic. And so that means 2 things. That means if multi-button mice are strictly out. You can't tell your left from your right. And also, people who are slightly dyslexic not only mix up left and right, but before and after in time, which means a modal interface. You might be confused about whether you set a mode before you hit a key that meant save instead of delete, or something completely dangerous like that. So Larry Tesler's famous. His license plate actually said no modes, but a lot of that came from the influence from Jeff Raskin as well, and maybe the fact that somehow when Larry Tesler was doing user testing, they smuggled in as his test subjects other people who were slightly dyslexic. I don't know if that's true or not. So, human interfaces. Again, that's come a long ways. It isn't just the Mac. There's a lot of prehistory. We went from punch cards to terminals, where you didn't need to sit in front of a mechanical device to feed your data into the computer. The graphical user interface goes way back to huge vacuum tube computers. The Strategic Air Command Sage computer, which was a vacuum tube computer that filled up a room larger than a basketball court. I think some of them were in multi-story buildings because they had to build 2 of them for redundancy. But essentially massive. But if you look at the pictures, there's a console with a huge round display and a light. Actually, it's a light gun, not a light pen, with a big cable on it where you could point at various objects and do graphical selection. And this was back in the earliest days of huge vacuum tube computers. Also, University of Utah experimented with light pen and sketch pad, so there's a lot of early history there. And of course, one of the most famous bits of user interface is Doug Engelbart's, I think, mother of all demos. And this was back in the late 1960s. Again, this is something that's online, actually with the title Mother of All Demos, because he basically demoed to the public the very first mouse, which was a prototype for him, and the very first, sort of windowed tasking system up on a monitor that at that time that they pointed a video camera to, and SRI did a huge bunch of stuff to make that demo work. But he demoed some of the earliest ideas of using an interface that wasn't just typing in commands, and this wasn't at Xerox, this was at SRI. But the mouse and other ideas ended up also at Xerox PARC in their research machines, the Xerox Alto, designed by Butler Lamps and others. Basically the Xerox PARC ideas, Apple had to rework them to make them, more usable after user testing. So they aren't really stolen. It's sort of, they just influenced the design of the Apple Lisa interface. But one, military project, user interface. Engelbart was, SRI wasn't into making stuff. I guess they were into licensing patents and stuff like that. Xerox PARC had a problem that their management wasn't really interested in anything outside of the market that they sold really expensive copy machines to, so they weren't going to build anything useful for it. The Xerox Star, I think they sold a few of. And then Apple's Lisa was sort of the problem of the innovator's dilemma, where they went out and talked to software engineers and customers and figured out exactly what they needed and wrote specifications with bus interfaces and I/O processors and a bunch of stuff. And that project essentially just ballooned up to being something that would be unaffordable even to a small business. I think, in today's dollars, an Apple Lisa would be like $40,000 or $50,000. Obviously, not a home computer or anything like that. So that they tried with the Apple Lisa, but it just, what it ballooned up to wouldn't have worked. And a lot of that, I think, was the innovator's dilemma. So I talked about that one already. So. Another reason the Macintosh succeeded was, of course, Steve Jobs was kicked out of the Lisa project. His personality at that time was sort of incompatible with the management that they brought in. So he got bumped aside, but still being, the founder, was allowed to search around and figure out something to do so he could sort of stay in the building. And so he sort of adopted the Macintosh project from Jeff Raskin. And Jeff didn't like mice, Steve did, so the mouse got added to the Macintosh. The graphical interface became a little more Lisa-like than what Jeff was proposing, was even more stripped down. Steve also, was allowed to borrow some of the Lisa engineers to help, teach the Apple engineers how to do things. And Jeff Raskin Bill Atkinson actually ping-ponged back and forth between the two projects. But in order to get permission to do the Macintosh project, to get continued funding to bring staff on board, he was kicked off the Lisa project, so he couldn't do a Lisa Junior. That was in the Lisa project's domain. He had to do something that he could at least claim was completely different. So he had to claim the Macintosh was going to be a much smaller, cheaper computer than anything that would fit in Lisa's market segment. That was the constraint on the project. It was the same constraint as Jeff Raskin, who said to make a product affordable, it'd have to use a minimal chip count. So people ask, why didn't the Mac do this, that, or the other? And the reason is, well, that's the Lisa. If we did this, that, or the other, it wouldn't have been any different from the Lisa. It would have been unaffordable. And the constraint from Jeff wanting to build a consumer, toaster typewriter type device, and Steve not being permitted to being built anything powerful enough to being called a Lisa Jr. was a constraint on the project that I think contributed to that it actually ended up shipping instead of being another canceled project or just an R&D project that never went anywhere. So it sort of, it's still the cost increase. It sort of got bumped up above Jeff's original $500 and $1,000 price points to double that. But that's, doubling is a lot better than, 5x or 10x. Oh yeah, prototype Lisa mouse. There are lots of cool artifacts in this museum here. It's one of the reasons it's so rare is, the Lisa mice are collector's items now. At the time I worked at Apple, they were throwing the ones that didn't work into a junk bin. I actually, was going, oh, that's interesting. So I pulled out 5 or 6 non-working Lisa mouse, and by exchanging part swapping back and forth, I actually made a couple working ones for myself, just so I could play with it. So that's what this is. So design influences on the Macintosh. Well, I talked about Jeff's paper, Computers by the Millions. Basically, constraint is it has to be manufacturable in volume, and that's like a video game volume as opposed to personal computing volume at the time. They're in very different market segments. Compact with low parts counts, that's where Burl comes in, a wizard at doing that stuff. Usable by a typical family member. The focus was always on, we don't want a computer that another person who's taken computer courses can use. We want a computer that would do something useful for mom or sister, Or then mom would buy the computer and the kid would learn from, the computer that was already in the home rather than the kid being a computer fanatic and wanting to get one himself. So designed by puzzle solving rather than designing to specification was important because Burl could again squeeze the cost down and keep it affordable. I already talked about that it had to be kept low enough it didn't compete with the Lisa project. Steve, another constraint that came in that again helped keep the project from ballooning was Steve wanted to do it in an automated factory. That wasn't successful, but I do remember him pitching the idea by saying, I want a factory where sand comes in one end, and completely built, boxed computers come out the other end. That's the way semiconductor technology turned out, that's not possible. But anyway, so basically, it was a design under constraints, and at the Mac 40th event, it's not only the hardware that was designed under constraints, but Susan Carey was asked about, did you really feel constrained or hampered by the fact that when you designed the Mac icons, they only had so many bits? I forget, it's a couple hundred bits, I can't remember the exact number. And she said, no. He said, artists like me think the constraint is actually freeing because it allows you to think more creatively about the little tool set that you have. And so that's interesting that even on the art side at the Macintosh, Susan Carey did the fonts and a lot of the artwork. She succeeded by design under constraints. Okay, so the Macintosh. What are its effects? Let's see. Without the Macintosh, it's arguable. There are other, the Xerox Star had other GUIs, but this particular GUI on the Macintosh was an outcome particularly because the Macintosh shipped. Cut, copy, paste. Larry Tesler introduced that for the Lisa. It came to the Macintosh. Now it's pervasive everywhere. Influence on how everybody uses the computer. Significant one is Bill Atkinson, after programming the Macintosh, he decided he wanted to do some software for the Macintosh, not only MacPaint, but HyperCard. What did HyperCard influence? It influenced what they were doing what was it? The Swiss research, CERN. It influenced what they were doing at CERN in developing hypertext and the World Wide Web and the web browser. Would we have things that looked like our web browsers without HyperCard, which depended on the Mac? Windows. Why does Windows exist? Bill Gates came down as part of the licensing agreement for getting the Apple Lisa and Mac technology was he would be writing applications for the Macintosh. That was a two-way agreement. If the Macintosh didn't ship and Bill Gates didn't have to write apps for the Macintosh, would he have licensed that Lisa technology? Would he have even seen as much of it as he did? Other influences, desktop publishing. Burl, after designing the Macintosh, designed the laser writer. Now, desktop publishing is a necessary enough function. It might have come along, but what other computer can you imagine desktop publishing being created for? You know, it would have been a much later generation. If you look inside the SDK for Palm, which is the first, small form factor computer, you'll look at their SDK and it basically looks a little like the Macintosh software development kit with all its GUI tools and APIs. So the whole idea of the PDI leading to the cell phone and the mobile phone also would have been impacted if the Mac didn't come out. I'll add that the 30% App Store thing also came from the Palm environment. So app stores might have been affected. So to finish, I'll finish with the fact that the IEEE considered the Macintosh important enough that they gave it a milestone plaque. Apple actually refused putting this in their own site, so it's at the Computer History Museum. Apple Macintosh created the personal computing epoch with its complete graphical user interface GUI platform in a compact, portable, low-cost package featuring a high-resolution bitmap graphics, one-button mouse, again, an innovative power supply and influenced by the Lisa computer. And let's see, is that, I think, that's another story, but my time is running short, so I think at this point I'd like to finish my talk. Thank you very much for taking your time to listen to me, and I can open it for questions.
So one of the big differences I find between Apple and Atari and Commodore and all the rest of it was the production of custom chips. Was it purely a bean counting thing where Apple wasn't large enough to do the initial investment to do the mass chip production? Was it a more conscious decision? What brought that about?
Well, I think doing custom chips was just coming into the range where it was affordable for a company of the size of Apple. Apple had previously hired several people with chip design experience, Walt Brodner and among other them, Wendell Sanders. We had several chip designers internal, so it became affordable. And second reason, I told you, both Raskin and Jobs didn't want too many chips on the board, so we had to integrate to satisfy their need for minimum parts count.
Hello, great talk.
Thank you.
You talked about how the Macintosh ostensibly would not compete with the Lisa. Can you talk, are you able to talk into how the relationship of the Macintosh and the Apple II GS and GX?
The GS is after my time. I'd left Apple before then, so I can't really comment on that. And I can't really comment on the specific negotiations between, Steve and the board of directors at that time for being allowed to play.
Hi, good morning. Thank you for being with us. I was kind of curious, since you're famously the only person I know of that signed both the inside of the Macintosh and the Amiga, were you at the original signing party for the Mac, or were you one of the folks that were kind of brought in later?
I was at the original signing party, and in fact, because I'd left Apple before it was introduced at that January event, I didn't know whether, anything would come of the fact that I was at the signing party. One of the most interesting things that happened to me was Steve Jobs actually came up to me after the end of that Flint Center event and told me, your signature's still inside.
So So about the radio interference stuff, I know some old computers. People wrote programs that had the computer create music via that radio interference. Is that something that was only possible, like the FCC regulations changed that newer computers had to prevent that sort of leakage, or?
I am not sure. I think before the Apple II, there weren't many digital devices in a typical home, so they wouldn't be things that would interfere with the TV. And they were starting to get reports that, people are bringing home their TRS-80s and Commodore PETs or whatever, and they would produce some RFI.
Again, like everybody, I thank you for coming here and presenting to us. At the beginning of your talk, you mentioned a number of different books which you thought were good references and proper references of history. Out of all of them, which one do you most recommend for people who are really interested in the accurate history of the Apple Macintosh?
Well, Andy Hertzfeld was actually there, so his book is good. And John Markoff and Stefan Levy, like I said, are Pulitzer Prize-winning authors who have interviewed myself and talked to many other members of the Mac team. So there are a lot of books written that I'm not sure if anybody at the Mac team actually talked to. So anyway, thank you.
Okay, everyone, thank you very much. And we need to draw a line there to give time for the next next session to set up. Ron, thank you very much.
Thank you.